The paleoclimate record teaches us that rapid climate change is really hard on societies. Climate changes at the end of the Ice Age contributed to megafauna extinctions and forced major changes in human subsistence. Droughts during the Holocene have toppled civilizations, and those were natural variation societies had no control over. We're causing changes faster and potentially larger than natural variations. With over 8 billion people to feed and house, many in areas vulnerable to climate change, the implications are staggering. Coastal cities face flooding from sea level rise. Agricultural regions face shifting rainfall and more extreme weather. Water resources are stressed by changing precipitation and glacial melt. Tropical regions could see temperatures exceeding human survivability thresholds for outdoor work during heat waves. Island nations could literally disappear. The humanitarian implications are enormous and unequally distributed. Those who contributed least to causing climate change are often most vulnerable to its effects. But understanding the problem is the first step toward addressing it. We know more about climate now than ever. We can see changes happening in real time with satellites and monitoring. We can model future scenarios with increasing accuracy. And we have technologies available that could dramatically reduce emissions if deployed at scale. Solar and wind are now cost competitive with fossil fuels in many places. Electric vehicles are becoming mainstream. Energy storage is improving. Carbon capture is being developed, though not yet proven at necessary scale. The challenge isn't really technological anymore. It's political, economic, and social. Getting 8 billion people to coordinate on emission reductions, equitably distributing costs and benefits, navigating competing interests, that's the hard part. Climate change is the ultimate tragedy of the commons. Individual actors benefit from burning fossil fuels, but everyone suffers consequences. Solving it requires collective action at a scale humanity has never achieved. Some people feel despair. The problem seems too big, changes too slow, obstacles too numerous. I get that. But humans have navigated existential challenges before. We survived the Ice Age through adaptation and innovation. We transitioned from hunting megafauna to agriculture, fundamentally transforming our relationship with the planet. We've overcome diseases, expanded lifespans, created technologies that would seem like magic to our ancestors. We're not helpless. We're just facing a problem requiring unprecedented coordination. The 100,000-year cycle will eventually resume, assuming we don't permanently alter it. The orbital mechanics haven't changed. Naturally, Earth would eventually slide back into glacial conditions tens of thousands of years from now. But we're writing a new chapter, one where human activity is a major climate driver, not just a responder. We're affecting the planet on a scale comparable to the astronomical forces that controlled climate for millions of years. No species has ever had this influence. It's both inspiring and terrifying. Future geologists studying sediments millions of years from now will see a clear marker. They'll see isotope ratios reflecting massive carbon combustion, extinction signatures, novel materials like plastics, and concrete in sediment. They'll recognize something unprecedented happened during this brief moment. Whether they'll also see evidence we successfully navigated the crisis, that's still open. The answer depends on what we do in coming decades. The cycle reminds us that climate is dynamic, sensitive to forcing, full of feedbacks and tipping points. It's not stable, unchanging background. It's an active system responding to inputs. For millions of years, inputs were natural. Now, we're adding a new input, and the system is responding. We're living through a moment unlike any other in Earth's 4.5 billion year history. For the first time, a single species, us, understands the global climate system even as we're altering it. The weight of that knowledge, that power, is almost unbearable. What we do with it now will determine Earth's trajectory for thousands, maybe millions of years. But the Ice Age cycles also teach us that life is resilient. Earth has weathered dramatic climate shifts before. Life survived the asteroid that wiped out the dinosaurs. It survived ice ages. It will survive this too. The real question is whether human civilization as we know it will thrive, or will we face massive disruptions that could have been avoided if we'd only had the foresight to act. I began by talking about the mystery of the 100,000-year cycle and how scientists patiently unraveled it. That same scientific community is now warning us about anthropogenic climate change, using the very methods that revealed the Ice Age cycles. If we trust the science that explained the past, shouldn't we trust it when it predicts the future? It seems clear we're pushing the system hard. We will see significant responses, and the window for avoiding the worst outcomes is closing rapidly. The Ice Age taught our ancestors to be adaptable and innovative. That's in our DNA. We can use those traits to navigate the challenge we've created, but we need to act collectively and quickly. The climate system has momentum and time lags. Actions we take today won't show their full effects for decades. But inaction today commits us to changes that will unfold for centuries. Every year we delay makes the eventual response harder and more disruptive. So, where does that leave us? We're 11,700 years into an interglacial period that should eventually end. We are armed with an understanding of how climate works, and we are actively changing it faster than natural processes typically do. The 100,000-year cycle that shaped human evolution is now being overridden by human activity. We've become a geological force. The only question is whether we use that power wisely or recklessly. The answer will determine what planet future generations inherit, and whether they'll view us as ancestors who rose to the challenge or as a cautionary tale of a species that understood the problem but failed to act. The clock is ticking. The cycle that sustained life for millions of years is still operating in the background. But for the first time, it might not matter, because for the first time, one of the species it created has the power to override it. What we do with that power in the next few decades will determine not just our future, but the future of countless other species sharing this planet with us. The Ice Age is over. The question is, what comes next? And unlike our ancestors, who just had to survive the cycle, we have the power to shape it. That's both an incredible responsibility and an incredible opportunity. It's time to see what we do with it.